Shoreline environments are then classified by their location relative to those tides. In the middle of this graph here, we have 0, which is the mean sea level that is between high and low tide. Here's mean low water, here's mean high water, and in between is mean sea level. So when sea level is referred to, it's that mean sea level line between high and low tide. That can change. These numbers here, NAVD and NGVD, are different datums of people or research groups who have said where is the sea level number. And it, again, changes depending on sea level rise or sea level fall. Above the spring high water here is the annual storm. So that would be a storm event that could bring in salt water into the terrigenous environment. And then above that is what would be the 100-year storm line, like a 100-year flood. Okay. But lower than the low water line is the open water, subtidal. The tidal flat is that area that changes. Sometimes it's exposed, sometimes it's not. And then the low marsh would be that area that is covered during high tide. High marsh is the area that's covered during the highest high tides, like the spring tides. And then there's a transition zone into what is truly that terrigenous environment. The third way that water moves in the marine environment is through currents. Look at surface currents first. On this map, the red currents are warm and the blue currents are cold. Cold water comes from the polar regions and goes towards the equator. Warm water starts at the equator and goes towards the poles. This is one way that heat is exchanged from the equator to the poles and allows for moderate temperatures on the Earth's surface. These circular motions of water are called the gyres, like the South Atlantic Gyre and the North Atlantic Gyre, and these are set into motion by different directions that the wind blows, and then also by the Coriolis effect. This next one is thermohaline circulation. Thermohaline circulation means, thermo is about the temperature and haline is about the salinity. Cold saline water is very dense and heavy, and warm, less saline water is less dense. So these currents are deep water currents. They go into the depths of the ocean, and they are going to be driven by density differences between those warm and cold waters. So whole ocean currents versus the sea surface currents. All right. Coastal erosion. Erosion sounds like a bad thing, but it's not. It's a natural movement of sand by waves and currents, and it's changed by the sea motion, whether or not there is sea level rise. Eustatic means a global sea level rise, a worldwide sea level change. And right now we are experiencing a few millimeters a year with eustatic sea level rise. There can also be dams along rivers that store sediment, and so they basically starve the beach budget, and there's going to be less sediment carried to our shorelines, and so the beaches are going to erode. There also can be man-made coastal structures, whether or not it's engineered structures or on purpose, or maybe a structure that not on purpose changes the way the waves move sediment. And then storms. Big storms can cause a whole lot of erosion all at once. They're probably the biggest movers of sediment. So they carry sediment out to sea, or storms can carry sediment towards the mainland over the dunes Basically, that would be the beach moving landward as storms carry sediment over the dunes. But we have our structures in the way, and so here's the coastal erosion along a little cliff. That house is obviously condemned. You can no longer live in it because of coastal erosion. I mentioned the sediment budget. Sand moving along our shorelines is going to all right, that sediment budget. We're moving sand along the beaches. Rivers are bringing in sediment, dropping it down at the deltas. The beach is reworking that sediment. There's something moving the sand called the longshore current. It's out here on this block diagram. As waves hit the shoreline, sediment is going to be carried in the direction of the longshore current, and that is going to be mostly in the direction that the wind is blowing. Sand is going to be stored in offshore sandbars. Sand also gets stored in inlets. Sand moves on and off the shoreline. Those processes that happen on land are also going to be happening out at sea. In this image, there is a loss of sediment from the beach through wind blowing sediment into dune fields, or from underwater little landslides. We could call these turbidity currents, where sediment is coming off of the continental shelf and out onto the deep sea floor. Rivers are bringing in sediment. The mouth of the river here is producing sediment in the delta, and that is getting reworked to form these barrier islands. Cliffs are eroding and pouring sediment into our ocean basins. And then that longshore drift, these yellow arrows, are moving sediment along the beach. Okay, so there are two different beaches depending on the season. The top block shows the winter profile. This is where there is a narrow beach with a berm, kind of like a high, almost like a step on the beach. That narrow beach then is a result of storms in the winter carrying sediment offshore into these sandbars. During the summertime, the more gentle waves are going to bring sediment back up the shore face and make a wider beach. And so the sediment is on the beach during the summertime, whereas in the winter it's carried offshore to a sandbar. Sand is stored in the inlets. So here is the mainland on our left over here. The light green is the marshy tidal marshes here, marshy tidal marshes. And then the yellow and oranges here are the barrier islands. Between the barrier islands are inlets, and those inlets have sandbars at the mouth. So here, the swoopy symbol here is a sandbar, 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 and lots of sediment is stored in those inlets. All right, transporting sediment. I've got a couple of terms here on this slide. The first one is longshore currents. This is when waves approach a beach at an angle as the water washes up and down the beach. Water, sand, and sand are moved laterally along the shore. So that is the current that is taking sediment along the shoreline, not just back and forth, but also side to side. We call that littoral drift. This is the drift of those big yellow arrows earlier. Sand movement along the beach in the same direction as the motion of the longshore current, typically in the direction of the wind. This process moves sand from one beach, that removal is called erosion, to another, and that is called accretion. So one beach is getting smaller as another one is getting bigger. That is a beach budget, where we're adding and subtracting sand. So in normal conditions, there would just be more sand in the pipeline and beaches wouldn't really disappear. We would just be moving sand around. All right, here's what that looks like, carrying sand. So these thin lines here are the wave crests. These are waves coming into a shoreline. This rectangle up here is the beach. This arrow here is the direction that the wind is blowing. So sand grains come up the beach and then go straight back down the beach and then up the beach, kind of in a seesaw pattern. swashing up and backwashing down. The backwash coming back down the beach is going to be kind of the shortest pathway, right? So it's going to be perpendicular to the shore face because of gravity. So the up and down making that sawhorse motion. So that the net addition then is a longshore drift down here to the left. So here, this image also shows path of sand. These wave crests are coming in, that zigzag motion, moving sand and water and people in the water, all that down the beach. A rip current occurs when that water piles up. So maybe lots of wind is blowing water into the shoreline, the sand particles moving up and down the beach. And as too much water piles up into the shoreline, all that water can rush back out to sea, and that is a rip current. All right. Humans can freak out, right? We're freakers. And, oh, roosters. The freak out would be if you have beachfront property and your sand is eroding. I would freak out too. So what they try to do is to add structures that modify the wave energy. And in North Carolina, that's pretty much illegal these days. There are a few projects that do get permitted on a really selective basis. That's because those structures are going to disrupt the usual flow and velocity patterns of the currents and change the beach budget and in turn change the shoreline. They refer to this in a positive way by calling it stabilization, but it's these engineered structures like here on the bottom left, a groin, or there on the right, a breakwater. So the groin is built perpendicular to the beach, and so the littoral drift for this beach would be moving sand from the left down the beach to the right, and the beach is getting trapped behind the groin on the left, and so the beach on the right is now eroding. In this image here, these breakwaters are usually put out off the shoreline to dissipate wave energy, but look what they've done to the beach. It's made this swoopy. It kind of looks neat, but is that what they really intended to change the shape of the shoreline? The image at the top here, that is, put me back high, that is a jetty. Jetties are built to stabilize inlets. Inlets are important to navigation, to our military, to the Army Corps of Engineers, to ships going in and out to sea, people going fishing, all that. So this jetty is one side of the inlet and another side on the other side of the inlet. And the longshore drift here is from the bottom to the top. So the beach on the bottom is really wide. We call this the fillet of sediment here. The beach in the top of the image is eroding away. See that? There's erosion here and accretion up here on the top. So that if you had a house back here on the top side of this image, you might be mad that your beach is eroding away. The bottom is a term we call New Jerseyification of the shoreline. In this case, this is something that happens a lot in New Jersey. They spend most of the money that is allocated for the Army Corps of Engineers for their shorelines. And this is called a seawall. What seawalls do is they build these walls to protect infrastructure, right? So maybe there's a highway or a parking lot. It says Exxon, see Exxon up there, grocery stores, and the waves were lapping up on this beach. Can't have it. So they built this wall. What the wall does, though, instead of the waves coming in that swash zone, right? They're going to come in and hit that wall. And what that wall does is amplify the wave energy instead of dissipate it. So it takes the beach away. Is that a place where you would ever hang out? I would not, ever. Okay. On the bottom here, what happens over time, put my face over the word groins. Groins here, this is a ton of groins that are protecting the curve in this shoreline here. And you have to build in a series of groins because if you put in one, the area next to that, like that jetty, is going to erode. If you put in another one, then the next area erodes. So over time, you end up getting sets of groins along these beaches. It doesn't make for a very pleasing recreational beach. The image to the top is the inlet, is Shallotte Inlet. This is the eastern end of Ocean Isle Beach. If you've ever spent time at Ocean Isle Beach, the eastern end is eroding away. I've spent my whole childhood there every summer. And this is Holden Beach, Holden Beach here to the east, and this Shallotte Inlet. And then this end of the beach is eroding away. And then over on the other end is like Sunset Beach and Bird Island. Those are growing as Ocean Isle Beach is getting eroded here on the end. So they have passed some legislation, and the Army Corps of Engineers got together with the people of Ocean Isle Beach, and they have agreed to put in what they call a terminal groin, so it'd be the end of the beach, to catch some sediment back here. This has upset the environmentalists because once you put in one, who's to stop you from putting in more? And so the Audubon Society got involved because that's bird habitat, and so they have stopped the construction for now of the terminal groin at Ocean Isle Beach. Here is, let's turn me off again. I'll look at that in a graph. This is the end of Ocean Isle Beach that's eroding. So on this graph, 0 would be nothing's happening, but it is eroding back here on that end of the island and accreting here at the western end of the island, and then over here at Sunset Beach, the beach is growing. So they have growing beaches, but the real negative here is that end of Ocean Isle Beach, Holden Beach as well is also shrinking. Okay. In this image, which way is the longshore drift? So see those groins at the top of the image? You have the groin, you have sediment on one side. So the deposition is going to be down here. If this is the longshore drift, here's the deposition of the sediment, and then those people over here are not getting any sediment. So the movement of the longshore drift is from the bottom of the image up towards the top. All right. The engineered structure slows down the currents, right? So it's slowing the current, which allows for the dropping of the load and the current behind, because the current behind that structure is gone down. The velocity has gone down to 0. Here's what seawall looks like. So a seawall makes just for a really icky beach. There's a highway right there, the seawall, and then they're constantly having to add sand to the beach side of the seawall. Here's a jetty near Miami. The jetty, you come out from the like intercoastal waterway out of this jetty and then out into the Atlantic Ocean. To the north up here, that beach is growing. To the south, though, the beach is shrinking. So look really closely down here at the bottom. They've put in a series of groins trying to trap more sand on the downdrift beach.